Yeah. So good morning. All of you can see my presentation. My screen is visible.
Yes, sir.
Okay, thank you. So in the last class, we started off with first unit. Okay, so that is soil exploration. Okay, so in that we already covered up to the objectives of the site investigation. Okay, so what are the main objectives of this site investigation? Okay, so first one is to determine the sequence, thickness, and lateral extent of the soil strata. Okay. Then what is the second objective? Just you have to collect that whatever soil sample present at the different depth. You have to collect that sample and test it in the laboratory. Okay, that is the second objective. Then third objective is to perform some in situ tests in the site itself. Okay, so that is my third objective. So and fourth objective is to find out the groundwater level. Okay, so at what depth the groundwater level, groundwater table is available. Okay, so because that is also going to affect my performance of the structure, right? So that's why we should determine on the groundwater level also. And the fifth objective is to see the drainage condition of the site and also to look for any site contamination or ground contamination or soil contamination. Okay, so maybe if wherever you want to build a structure, if that soil is contaminated with some industrial waste or not, that also you should look for. Okay, so that is those are the main objectives of the site investigation. Okay, and then after that we have seen the stages involved in the site investigation. What are the different stages? Okay, so that broadly there are two stages of the site investigation. Okay, so first one is what this is the preliminary investigation. Okay, so you have to carry out the preliminary investigation. So in the preliminary investigation, what you will see some geological, we'll do some geological survey. Okay, and also we will study some local topography, and if at all any excavations are available, and also drainage pattern and the natural or man-made features we will see. Okay, so in that is also comes under the preliminary investigation. Okay, so in the third step, we'll try to carry out some geophysical investigations. Okay, so what are these geophysical investigations? We'll see in coming lectures. Okay, so there are two geophysical investigations available for in your syllabus. So those things we'll discuss in my towards the end of this unit. Okay, so these three steps will constitute my primary investigations. Okay, so in the detailed investigation, what are the things you can do? First thing, you can drill or you can do some borings. Okay, so you drill a borehole, and then once you drill the borehole, then you can collect the samples. Okay, so what are the different types of samples available? One is the disturbed sample, another one is undisturbed sample. Two types of samples we will collect during site investigation. Okay, so this undisturbed soil samples meant only to do index properties. Okay, so only to find out the index properties will use this undisturbed samples. Okay, so sorry, just a minute. I think where is my eraser? Yes. So undisturbed samples will be used to find out the engineering properties. Okay, so undisturbed samples will use it to find out the engineering properties. Okay, so what are the engineering properties? Like C, cohesion, and pi. Okay, so these disturbed samples will be meant only to find out the index properties. Okay, so when you will call a sample as a disturbed sample and when you will call a sample as an undisturbed sample, that we will see in the coming slides. Okay, so right away, if I want to tell, if I want to explain about disturbed and undisturbed, only thing you should remember that the arrangement of whatever soil particles are there. Now, if it is disturbed, then it is called as disturbed sample. Okay, so if the arrangement of the solid particles is preserved as it is in the ground, then it is called as undisturbed samples. Okay, so in detail we'll discuss more about this disturbed sample and undisturbed sample in coming slides. Okay, so how to, and also how to obtain these disturbed and undisturbed samples. Okay, so to obtain these samples we have some samplers. So we will use some samplers like open drive, thin walled. Okay, depending on the thickness of wall thickness of these samplers, so we will define whether the sample is disturbed or undisturbed. Okay, so everything we will discuss in detail in coming classes. Okay, so and then the third step in the detailed investigation is to carry out the laboratory test or some field test. Okay, so both also you can carry. So whatever sample you will collect now from the undisturbed samples or disturbed samples, we will take those to laboratory and then we will do some tests. Okay, and also once you have done this boring, no, so in the boring so you have a hole like this in the ground, right? In the ground you made a hole by using this some kind of borings. Okay, so in that we'll carry out some field test like a standard penetration test, cone penetration test, or dynamic cone penetration test, or pressure meter test. All these are not in your syllabus. Okay, so these is out of your it is not in the scope of your syllabus, so I won't discuss these field tests. Okay, as far as laboratory tests are concerned, in detail we will study in 7th semester. There is a lab called geotechnical engineering. Okay, in that also we will in detail we will do some laboratory tests. What are the different laboratory tests are available? Okay, so the extent of soil exploration, it is depends on the importance and type of the project. Okay, so whether you are dealing with some small scale project like maybe some residential, individual residential building, maybe 1 or 2 floor building, or are you dealing with very big structures like multi-story buildings, or maybe some power plants or some dam construction. So the the soil exploration extent and also the number of boreholes, it depends on the importance of the project, and also it depends on the available soil strata in the site. Okay. So in detail we have already discussed this trial pits. Okay, so either to see the soil strata, either we can go for the trial pits or you can go for the borings also. Okay, so in the boring, so trial pit, what is the trial pit? Just you make a one excavation in the ground. Okay, so maybe desired depth will be the desired depth of excavation should be maybe 1.5 to 2 times the width of the footing. Okay, and also with this trial pits, the main advantage of this trial pit is you can see the stratification of the soil strata. Okay, so that is the main advantage of this trial pit. And also another very important advantage of this trial pit is with the trial pit you can get this kind of a block samples. Okay, block samples. Okay, so with this kind of block samples, these are block samples are called as undisturbed samples. Okay, so these are called as undisturbed samples. So these are very helpful to find out the engineering properties in the laboratory tests. Okay, like C and phi value of this soil. Okay, so these are the advantages. But what is the disadvantage? Disadvantage is the depth of the trial pit is restricted. Okay, so maybe you can go up to maximum 1 to 4 meter depth. Okay, so beyond that you can't go for the excavation. Okay, so that is the major disadvantage. Okay, now coming to the borings. Okay, so what are the different, see again borings also there are 5 different methods are there. Okay, so to make a hole in the ground, okay, to make a borehole in the ground, this is borehole. To make a borehole, this is sectional elevation and this is the plan. Okay, so in the plan if you see, it look like one small hole. Okay, if you see the sectional elevation, it look like this. Okay, so borehole. To make this borehole, there are 5 different methods are there. Okay, so first one is the agar boring. and the second one is the shell and agar boring, and the third one is the wash boring, and fourth one is the percussion boring, and fifth one is the rotary boring. This is rotary boring. So why there are different boring systems are there? Because depending on the nature of the soil, depending on the nature of the soil and position of the groundwater table, and also the likely disturbance of the soil samples that have to be taken. Okay, so depending on those these parameters, you can use different methods are there. Okay, so each boring systems have its own advantages and disadvantages. Okay, so no one system is perfect. Okay, so both all are having some advantages and disadvantages. Okay, so depending on the your ground condition, and also your intent to what kind of a sample you want to collect. Okay, so depending on that you can choose among these different methods. Okay, so we'll discuss one by one. First one is agar boring. So in the agar boring, again in the agar boring we have two types of agar boring. One is the hand operated agar boring, and another one is the mechanized agar boring. Okay, so we'll what is hand operated agar boring? Hand operated agar boring looks like this. Okay, so this is hand operated agars. Okay, what we'll do, we'll try to push the this agar inside the ground, and simultaneously will apply some torque. Okay, so with the combination of your vertical pressure and torque, we'll try to insert this agar inside the ground. Okay, it can be used for boring holes up to 6 meters. Okay, so it can with this agar borings or hand operated agars, you can go up to 6 meters in the soft clay. Okay, so this is not suitable for very stiff clay. Okay, so because stiff clay will offer a lot of resistance to the penetration or rotation of these agar borings. Okay, so that's why it is not suitable for the stiff clay, and also the soil and also the ground, if it consists of a lot of boulders, okay, or a lot of stones, then also this kind of boring, this kind of agar hand operated agars are not suitable. Okay, and whatever samples you will get, they are highly disturbed soil samples you will get from this one. Okay, so why it is highly disturbed? Because whatever particle arrangements are there, no, in the soil, that will be disturbed. Okay, so by the time the soil will get at the ground level, it will be disturbed one. Okay, so the arrangement of the soil particles will be distorted. Okay, so that's why we will get disturbed soil samples in the agar boring. Okay, or hand operated agars. So what are the advantages and disadvantages of this hand operated agars? One is it cannot penetrate in the hard strata. Okay, and also it cannot go beyond 4 to 6 meters. If strata having stones and gravels, also it is not possible to penetrate the agars, and also the in situ tests like CPT and SPT cannot be carried out. Okay, and no undisturbed samples are obtained. And then coming to the power driven agars. Okay, so in the again in the agar system only, the first one we have discussed hand operated agar. Now we will see a power driven agar. Okay, so power driven agar means we'll use instead of manually pushing and rotating the agars, we will use some machines. Okay, so with the help of those machines, what we'll do, we'll push the agar, and also at the same time we'll try to rotate the samples. Okay, so it is most popular method, and they are truck mounted and equipped with the continuous flight agars, which is mechanically rotated to cut the soil. Okay, so there will be some hydraulic or some machine. Usually we'll use oil engines. Okay, to drive this power, to get the power, so that it will be pushed inside the ground, at the same time it will be rotated. Okay. The central stem can be solid or hollow. Okay, so if you see the central stem, so this is the central stem. So this central stem is there. No, this will be, it may be solid. It may be solid, or it may be hollow one. Okay, if you see this one, okay, so this is the solid one and this is the hollow one. Okay, so see, or you see this figure. Okay, you see inside there is a hollow one. There is a space inside this agar. Okay, so this thing will go inside this one, and then we will try to rotate or we will try to cut the soil sample. Okay, then what will happen? We will remove this this central portion. Okay, so this central portion will be removed, and inside this hollow portion, what we will do? We will insert the sampler. We'll insert the sampler, and then we will collect the soil samples from the ground. Understood? No, the mechanism of this power-driven agar. Okay, so in it is a hollow agar system, but it may also have a solid one. Okay, solid one means you can't remove this central portion. Okay, so it will be fixed inside the this agar. Okay, so if you want to collect the soil sample, then you have to remove entire assembly, your agar assembly, and also the central portion of this assembly. Everything you have to remove. Then you insert the sampler inside the ground, then get the soil sample. Okay, so the second type of agar system is called as shell and agar boring. Okay, so in the previous one, what we did, we only used the agar system. Okay, so in the agar also hand operated and also mechanically operated. Okay, so now we'll see the second type of boring system, that is shell and agar boring. Okay, so it is suitable for corrosionless soil or a stiff clay. So and the tool consists of a agar for soft and stiff clay. Okay, so if you have this kind of soil like a soft or stiff clay, then what we will do, we will use the agars. Okay, so if you have a very stiff clay, or hard clay, then we will use the shell system. Okay, we'll use the shell system. And a hand rig may be used for a vertical boring up to 200 mm dia and 25 meter depth. Okay, so either you can operate this shell and agar boring system with the hand rig, but if you use that hand rig, what will happen? You will get a diameter of the borehole as 200 mm, and also you can go up to 25 meter depth. Okay, so if at all, if you are in alluvial deposits, if you in alluvial deposits, then you can go up to 50 meter with the help of this shell and agar boring. So, and the next point is no water shall be added while boring through the soft corrosionless soil. Okay, so you should not add any water, because what will happen, the quicksand condition may occur. Okay, so what is quicksand condition and all, you would have studied in your previous semester. Okay, so in that quicksand condition means it will, all the shear strength of the sand will be lost and it will behave like a water. Okay, so that kind of situation may arise. That's why we should not add any water, especially while drilling in the soft through soft corrosion soil and corrosionless soil. If you are drilling a corrosionless soil like silt and sand, like silt and sand, if you are drilling, then you should not add any water. Okay, then a baler should be used to remove the soil cutting. So while boring through the corrosionless deposit, silt and sand below water table, the water in the casing shall always be maintained at or above the water table. Okay, so it is essential that the casing is kept full of water or with 5% of bentonite slurry. And the last point is shell is used to get the disturbed soil sample at a regular interval or whenever there is a change in the strata. Okay, now we will see the third type of boring system. Okay, so that is a wash boring. So what is wash boring? So wash boring, it can be either mechanically or manually operated. Okay, so either you can operate, or also you can operate manually. Okay, so what is the procedure in the wash boring? The procedure is, first what we will do, we will drive the casing pipe. Okay, so where is my casing pipe? Okay, so this is the casing pipe. First, what I will do, I will drive the casing pipe inside the ground. Okay, like this. First, a casing pipe will be driven. Then, water is forced through the hollow drill rod, which has a chopping bit at the end. Okay, so now you see this is the drill rod. We change the color so that you can see. So this is my drill rod. Okay. So this drill rod will have a hollow portion. Okay, so through which will send the water in a high pressure. Okay. Then what will happen? Soil cut floats up through the annular space. Okay, so now once what will happen once you send the water and this drill rod is there. Now this drill rod is attached to the chopping bit. Okay, so this chopping bit will cut the soil. It will cut the soil, and whatever water is there, that water and this it will mix with that whatever chopped off soil is there. It will mix with that one, and then it will be pushed outside to this annular space. Okay, so this water will act like a lubricant. Okay, so it will cool off this chopping bit, and also it will act like it will take off this whatever cut material is there. Along with that, it will take off, and it will come and it will be stored in the some pit will be made inside here. So in that pit, that water along with that whatever chopped off soil is there, that will be stored here. So it is suitable for soil exploration below groundwater table. Then it can be used for all types of soil except in a hard soil or a rock. Okay, so if you have a rock, then you cannot use this wash boring. So soil is severely disturbed and is useful only for a soil layer identification. Okay, so what will happen once this cutting will happen now? So due to that cutting, all the soil particles will be highly disturbed in state. Okay, and see whatever cut off material is there, that will mix with water, and it will flow through this annular space, and it will be stored inside this pit. Okay, so once with that there, whenever the color of that water along with that soil particles will change, then you can understand that okay, the soil strata is changed. Okay, so through this kind of mechanism, whatever soil you will get at the bottom of this pit now, that will be very highly disturbed soil sample. Okay, so that will be used only to identify the change in the strata. So undisturbed samples can be obtained. Okay, so through this wash boring, you can obtain undisturbed samples also. How we can obtain? So you remove this whatever. Suppose you have drilled up to this level. Then what you can do? You remove this chopping bit, and then you attach the samplers will be there. Okay, so thin walled sampler will be there. That sampler you attach it here, and then push inside the ground. Then you push inside the ground. And then once you get the soil sample, then take out the entire assembly outside and then remove the soil sample. Okay, so whatever soil you will get through from this kind of mechanism will be undisturbed soil samples. Okay, so now if you remember, from the wash boring you can get undisturbed soil sample as well as disturbed soil sample. When you will get a disturbed without that sampler. Okay, so once the soil is cut and it mixed with water, it will flow. It will be flushed. It will be flow in between the annular space between the boring and the rod. Okay, so then it will be collected in the some pit. Okay, so in there you will get a disturbed soil sample. Okay, how to get undisturbed soil sample? To get the undisturbed soil sample, you remove this entire assembly. and then you remove this chopping bit, then replace the this chopping bit with the samplers. Okay, you replace with the thin walled sampler. Okay, so thin walled sampler, it look like this, look like this. Okay, so a simple in the later PPT I will show the figure of this samplers, thin walled sampler. So that we will attach and then we will push inside the ground. So this is about wash boring. Okay, so the depth of the depth of borehole you can achieve through the wash boring is up to 30 meters. Okay, to operate continuously, what will happen? Hollow drill rods has to be added. Okay, so that means this drill rods will be there. Once one drill rod, if it is over, then you take another drill rod and attach to this assembly, then again push inside the ground. Okay. So with the help of this wash boring, what will be, we will get a dia of 150 mm borehole and also a length of 15 to 20 meter depth you can achieve through this wash boring. Okay, so then we cannot, we can conduct in situ tests inside the hole through this whatever with wash boring we have done. No? In that borehole we can carry out in situ tests like SPT and CPT, because we have enough dia borehole so that your SPT and CPT can be fit inside this 150 mm dia borehole. So less disturbance of soil samples compared to other, hence it provides a good quality undisturbed soil samples. Okay, so as I previously mentioned, from this wash boring you can get both the disturbed and undisturbed soil samples. If you use a thin walled sampler, then you will get a undisturbed samples. What are the limitations of this wash boring? The progress is very slow. So very slowly the drilling will happen. So if gravel and cobbles are encountered, and also it cannot penetrate into the rock. These are the two limitations of this wash boring. Okay. So to address this limitation, it cannot penetrate into the rock, then we will use a rotary boring. Okay, so this is the some field photos of wash boring. Okay, you see this is the assembly. See, these are the drill rods. These are the drill rods. Okay. Okay, so the next type of boring is the rotary boring. In the rotary boring, what we will do? It is almost similar to the wash boring. Only thing is we will change this drilling bit. Okay, so here whatever drilling bit is there, this we will use either a diamond or a tungsten drill bit will be there. That we will use inside this borehole. So what is the procedure in the rotary boring? First, what we will do? We will push a drill bit by the weight of the equipment, which is rotated by a motor. So this is just, I have shown a small assembly of this rotary boring. So the full assembly I will show in the next slide. But what is happening inside the ground I am showing here. Okay, so this is the drill rod. This is the drill rod and this is the drill bit. So this is the drill bit. So what will happen? This drill rod along with this drill bit will be pushed inside the ground with the help of a weight of equipment and also with the rotation of the motor. Then what will happen? The rotation cuts the material which is washed out with the drilling fluid under pressure. Okay, so along here also we will use some drilling fluid. Okay, so maybe water as a drilling fluid we can use, or you can even use water along with some bentonite. Okay, that is called as bentonite slurry also we will call. So that will be pushed inside this drill rod. Okay, then a drilled fluid supports the borehole wall and cools the or it will lubricate the a drilling tool also. Okay, so this whatever this drill fluid will push inside this drilling rod now. So it will have a two functions. One is it will support the borehole so that it will not be collapsed. How it will support, I will tell you in the coming slide. Okay, so how this drilling fluid will support the borehole, and also it will act like some cooling of material. Okay, so because once it is cutting, no, or continuously, if it is your drill bit is rotating, so it will be heated up. So to cool down or to act like a lubricant, this water or drilling fluid will be injected inside the these drill rods. The procedure is suitable for sands, clays, and rocks. So it is not suitable if soil contains a high percentage of gravel-sized particles. Why it is not suitable in the high percentage of gravel-sized? Because once this drill bit is rotating, along with that rotation, your gravels, whatever gravels are there, those also start rotating along with this drill bit. So that with this relative motion, there is no progress of the borehole inside the ground. Okay, so that's why if you have a high percentage of gravel size particle, then this rotary boring is not suitable. Okay, so what you should do then, there is another method of boring that is called as percussion boring. Okay, so in the next slide I will show what is the percussion boring. Everything we will discuss in the next slide. Okay. And to obtain the samples, the drilling bit is replaced by a sampler or a coring bit. Okay, sampler will use if your soil is there. If you have a soil, then we will use a sampler. Okay, so if you have a rock, then we will use a coring bit. If you have a rock, it the depth of the drilling can go up to 7,500 meters. Okay, so 7,500 meters is a very huge amount. So which is usually used in the oil industry. Okay, so in the geotechnical purpose, the depth we can go maybe around 20 to 30 meters is enough for us. But in case of oil industry, they will go kilometers together inside the ground. So for that purpose, this rotary boring will be useful. Okay. So this is the assembly of the rotary boring. Okay, you see this is the rock core. So in that rock core, what will the core bit will call rock core bit. Okay. In that bit, what the rock will be stored inside. Okay, so once it is going inside the ground, once this rotation happen, what will happen? The rock will cut and it will be stored inside this core bit. So this is the entire assembly of the rotary boring. Okay. So this is the entire assembly of it. Okay, the next type of boring is the percussion boring. So what is the percussion boring? Boring rig consists of this derrick, power unit, winch, carrying a thin steel cable which passes through a pulley on top of the derrick, mechanically operated. Okay, so you see this is the hole. Okay, so inside the hole, so this is the cable, so this is the pulley. Okay, so over that pulley will have some kind of a rope system. Okay, here some winch unit will be there. That winch unit, with that winch unit you can raise this bit above the ground, and then we will allow it to fall under gravity, and whatever solid particles are there, like boulders and all, they will be crushed under that weight, and then they will make it into powder. What is the procedure include? The powdering the formation by repeated blows, alternatively raised and dropped, of a heavy bit or chisel inside the casing pipe. Okay, so now you see this is the casing pipe. Once you drive the casing pipe, with this chisel, what we will do, we will raise the chisel and then we will allow it to fall under gravity. So under its weight, whatever formation is there, that will be crushed and made into powder. The pulverized material forms a slurry with water. Along with this, will inject some water also. So whatever pulverized material is there, that will mix with water, and it will make a slurry. It will make a slurry with water, which is removed by a baler. Okay, so with the baler system, we can remove that slurry. Okay, so it is suitable for boulders and gravelly soil. Okay, so it is suitable for boulders and gravelly soil in the river deposits. Okay, so usually in the river deposit, what will happen? No, so these the gravel content will be high. No? So in those circumstances, you can use this perfusion boring. So disturbed samples will be obtained. Okay, so here through this perfusion boring, what will happen? We will get disturbed soil samples. Okay, so it is limited to depth of 50 to 60 meter. Okay, so the depth of investigation is limited to 50 to 60 meter. Okay, so these are the 5 different types of borings. Once you do this boring, then comes the stabilization of the boreholes. Okay, so how we can stabilize the boreholes? So see, once you make a borehole inside the ground, no? Once you make this borehole, what will happen? If you encounter a very weak soil strata, very weak soil strata, what will happen? This will collapse. This wall of this hole will collapse, and it will obstruct you to penetrate inside the ground. Okay, so to avoid that, what we should do? We should stabilize the borehole. How it can stabilize the borehole? There are 3 different methods to stabilize the borehole. One is either you use simply some water. You use some water. With that water, you can stabilize the borehole, or you can stabilize by some casing pipe. You insert some casing pipe so that the collapse of borehole will be arrested. So here, if you have a very weak soil, no, here you provide some casing here. Some steel pipe you insert inside the ground. Okay, so that the collapse will be restricted. Okay, so that also that is the second method. And what is the third method? You can use some drilling fluid. Okay. So what is the drilling fluid? Drilling fluid, like some water along with some bentonite slurry will use, because once you mix that water and bentonite slurry, its a unit weight will increase. Okay. So what is the unit weight of water? Unit weight of water is 1 gram per cm cube. But unit weight of once you mix the bentonite slurry with water, then its unit weight will increase. Once its unit weight will increase, then the pressure applied on the ground also will increase. Okay, so I will show in the through this figure. Here is this one. Okay, so what are the different methods of the stabilization of the borehole? There are 3 methods. One is either you can use only just a water, or you can use a casing pipe, or you can use the drilling fluid. Okay. So in the water, what will happen? It is not suitable in a partially saturated soil. Okay. So if you have a partially saturated soil, this water is not suitable. And also, it is used only in the rock and the stiff clay. Okay. If you have a sandy type of soil, or if you have a very soft clay, then water alone cannot stabilize the borehole. Okay. Then second method is stabilization by casing. Okay, so how we can do stabilization by casing? See, through picture I am showing here. So this is the strata. This is a weak soil strata. Okay. So due to this weak soil strata, what will happen? The collapse will happen here. Okay, so like this, some collapse will happen. So to avoid this collapse, what will you use? If soil is loose condition and high with the water table, you will use some mild steel casing pipe. We'll use some mild steel casing pipe is required for stabilization of the borehole. Okay. So this is the second way of stabilizing the borehole. And what is the third way of stabilizing the borehole? You can use some drilling fluid. What are those drilling fluid? You see, now you see. So bentonite slurry will be used to stabilize the borehole, which contains high content of montmorillonite. Okay, so I think you already studied this clay mineralogy in your fifth semester basic geotechnical engineering. Okay, so there we have this montmorillonite clay. Okay, so this montmorillonite clay is a highly reactive clay. So whenever you use this bentonite slurry, so this in the bentonite slurry, this montmorillonite clay mineral will be very high in percentage. Okay, so which will exhibit a thixotropic property. It will exhibit a thixotropic property. What do you mean by thixotropic property? Thixotropic property means if the soil, if you disturb little bit with the vibration, if you disturb, then it will lose its all strength. So that is called as a thixotropic property. Okay, so now you see this is the borehole. Okay, so this is the borehole I'm talking. Okay, so this is the borehole. What will happen if the water table is here? If the water table is there, what will happen? Water will try to flow like this. Water will try to flow like this, and it will apply a lateral soil pressure. Okay, it will apply some pressure. So due to that pressure, what will happen? The wall may collapse. The wall may collapse. To avoid that, what we can do? You fill this borehole with a bentonite slurry, whose specific gravity or unit weight is more than water. Okay, so the unit weight of water is 1 gram per cm cube. 1 gram per cm cube, and the unit weight of this bentonite slurry will be around 1.05 gram per cm cube. Okay, which is higher than the water. Okay, so that's why whatever this lateral pressure is there, that will be that will be resisted by this bentonite slurry. Okay, so with that mechanism you can stabilize the borehole. Okay. Okay, so coming to the sampling technique. Okay, so now this is very important concept. So in the examination also many times they asked the questions based on these sampling techniques. Okay, so there are two types of samples. What are those two types of samples? One is the disturbed sample, and another one is the undisturbed samples. So this disturbed sample is like it look like this, something like this. Okay, so whatever with the help of this shovel and all, you will remove the soil. No, see the arrangement of all these solid particles are now disturbed as compared to how they are arranged in the ground. Okay, that's why they are called as a disturbed samples. So these are the undisturbed samples. Undisturbed samples means the arrangement of solid particles, whatever the arrangement of the particles are there, they are intact. Okay, so they are not disturbed by the soil sampling mechanism. Okay, so this is called as a block samples. This is the block samples, and this is the tube samples. Okay, so you see these are the tube samples. Okay, so these two types of samples will comes under a category of undisturbed samples, and these two types of samples comes under category of disturbed samples. Okay, so the bottom line, how you can distinguish between disturbed and undisturbed is just you look at the arrangement of the solid particles. If the whatever arrangement of solid particles or solid particles is available in the ground, if you preserve, if you are preserving that, then you can call those samples as undisturbed samples. Okay, if you are not able to preserve that arrangement of the solid particles while collecting the sample, then those samples are called as disturbed samples. Understood? No? The difference between disturbed samples and undisturbed samples. The arrangement of the particles is not preserved. Here, arrangement of the particles is preserved. Okay. Again, in the undisturbed samples, either you can get through a block sample, or you can get through a tube samples. Okay. So I was telling you thin-walled sampler. No? So this is the thin-walled sample. Thin-walled sample. Sorry, thin-walled sampler, I should call it. Okay. So again, in the disturbed sample, okay, we have some category. So when you will call a disturbed sample, you see, as I earlier mentioned, those soil samples where natural soil structure get destroyed because of sampling operations, those are called as disturbed samples. So when you will call disturbed samples, those soil samples where natural soil structure get destroyed because of sampling operations. Due to this sampling operation, what will happen? Your water soil, this arrangement of the particles is there, those are disturbed. Then it is called as a disturbed soil samples. Okay, so boring tools and excavation equipments, with that help, whatever sample you will get now, those are called as disturbed samples. Again, in the disturbed samples, we have two types. One is the representative sample, another one is the non-representative sample. Okay, so when you will call a representative sample, when you will call it as a representative sample, the disturbed sample in which the natural moisture content and proportion of mineral constituent are preserved. This is very important. Proportion of mineral constituents are preserved by suitable precautions. Okay, so it can be obtained through a trial pit, channel penetration test, or agar sample. Okay. So those kinds of samples are called as representative samples. Representative samples means, of course, it is a disturbed sample. Of course, it is a disturbed sample, but you are preserving the mineral constituent, proportion of mineral constituents. Okay, so like if you have a maybe sand, some 50%, and some clay, maybe around some 40%. Okay, so whatever this proportion is there, that if you able to maintain or if you able to preserve that, then those are called as a representative samples. Then on other hand, they also called as non-representative samples, which is also called it as a disturbed samples. So non-representative samples, when you will call it as a particular sample as a non-representative sample, if the soil from various layers are get mixed up. Like suppose this is my ground, this is my ground, and this is my layer 1, and this is my layer 2. Okay, so if the soil from the layer 1 and soil from the layer 2 get mixed up by the time we collect the soil sample, if the layer 1 and layer 2 get mixed up, then those samples are called as non-representative samples. Okay, so non-representative sample means from the different soil layers the soil will get mixed up. Okay, so you cannot preserve the proportion of the constituent particles. Okay, so that's why they are called as non-representative samples. What are the features of these disturbed samples? So first feature is the soil structure is significantly damaged. The soil structure is significantly damaged or completely destroyed. That is the first feature. And then second feature is it still retain the same composition and grain size. So whatever the composition of soils are there, those are still retained here. This kind of soil is suitable for classification and compaction purpose only. You can't use this disturbed samples for the engineering to find out the engineering properties. Only you can use this disturbed samples for the classification purpose or index properties, to find out the index properties. Then what is the fourth feature? The fourth feature is soil can be excavated from trial pit or obtained from tools used to advance the borehole. Example, agar or clay cutter. Soil can be excavated from the trial pits. These kinds of disturbed samples are there. No, these kinds of disturbed samples can be obtained from the trial pit, or it can also be obtained from the boreholes, maybe with the help of agar borehole or a clay cutter. So, any doubt till now? If you have any doubt? Yes. Any doubts are there? Kiran Kumar Rathod, are you there, Kiran?
No, sir.
Any? Are you able to follow whatever I am teaching now?
Yes, sir.
Okay. What about others? Priyadarshini, are you there, Priyadarshini?
Yes, sir.
So, any doubts are there till now?
No, sir.
So, you are familiar with the disturbed sample and undisturbed samples, right?
Yes, sir.
Huh? Okay.
Yes, sir.
Okay. Okay. So, I will continue for another 5 minutes. Then I will end up the class. Okay. So, bear with me for another 5 minutes. Okay. So. Yeah. So till now we discussed about disturbed samples, and also we have seen the features of the disturbed samples. Okay. Now we will see undisturbed samples. Okay. So when you will call it as an undisturbed sample, if the soil material is subjected to a minimal disturbance. Okay. So if it is subjected to minimal disturbance and is suitable to find engineering properties such as shear strength and consolidation parameters or permeability parameters. Okay, so undisturbed samples usually we will use it for the to find out the engineering properties. So these undisturbed samples will be used to find out engineering properties. What are the engineering properties? Engineering properties like shear strength parameters, C and phi, and consolidation parameters and permeability parameters. Permeability parameter like K, and consolidation parameters like coefficient of permeability CV and CC. To find out those things, we will use these undisturbed samples. Okay, so when you will call a sample as undisturbed samples, if you are able to maintain the arrangement of the soil particles, if you are able to maintain this arrangement of the soil particles, then you can call it as a undisturbed samples. Okay, so what are the features of the undisturbed samples? Feature is the soil structure and water content of the soil sample is preserved. So like whatever in the natural ground level, whatever arrangement of the solid particles and whatever the water content is there, that if you are able to preserve them while collecting the soil sample, then they are called as a undisturbed samples. Okay, so that is the one feature of the undisturbed sample. Then what is the second feature? Such samples are mainly used to find out the shear strength or consolidation or permeability test. Okay, so these will be used to find out these parameters. And then in trial pit, the soil can cut by hand from the pit bottom or sides. Okay, how we can obtain these? How we can obtain the undisturbed sample? So if you have a trial pit, then you cut the soil sample with your hand like this you can cut it. Or if you are in the borehole, then then you get this thin-walled sampler. Okay, thin-walled sampler. Then with that thin-walled sampler, then you insert inside the ground, or you insert this assembly inside the borehole. Then push it from the top. Okay, with that help also you can get the undisturbed soil samples. And what is the fourth feature? In boreholes, the samples can be obtained by driving or pushing the sample tube into the soil at the bottom of the borehole. Should be covered with the molten wax. Okay, once you get the soil samples from this one, what do you have to do? You have to cover the soil sample in the wax. Okay, why you should use the wax? Because see, ultimately from the site you have to take these soil samples to the laboratory. Okay, so by the time you reach the laboratory, whatever water content is there, now that can be evaporated. Okay, because sometimes what will happen, site will be very far away, maybe like 10-hour journey of like 1 day journey away from your laboratory. Okay, so in those conditions, what will happen, while transporting, you may lose the natural water content, and also you may lose the arrangement of the soil particles, because of once you are carrying out the samples, once you are transporting the samples due to vibrations, what will happen, this arrangement will be disturbed. Okay, to avoid that, what we will do, we'll use some molten wax, we'll put, okay, so that it's the natural water content and also the natural these soil particle arrangements will be preserved while transporting, even while transporting also. Okay, it is impossible to obtain completely undisturbed samples. Okay, so of course, even these undisturbed samples also subjected to some kind of a disturbance. Okay, so it is not 100%. We cannot claim these samples as 100% undisturbed samples. Okay, so sometimes what will happen, because of your overburden pressure, because of your reduction in overburden pressure, what will happen, these samples will be either they may be they may undergo swelling, or they may undergo contraction. Okay, so due to that process also, sometimes the little bit of disturbance will be caused to the soil samples. Okay, so whatever claim you are doing by writing it as undisturbed samples, it is not actually 100% undisturbed samples, but to some extent it is called as an undisturbed sample, because always in the nature we are little bit disturbance will be happened while collecting the soil samples. Okay, so this is the table where see, these are the properties of the soil, and this is the type of test, and this is the sample type. Okay, so see, if you are doing some classification tests, if you are doing some classification tests like identification, grain size distribution, consistency limit, moisture content, unit weight, for those purpose you need a disturbed samples. Okay, so D means disturbed samples, and UD means undisturbed samples. Okay, so UD means undisturbed sample. You need an undisturbed sample to find out the moisture content. You need a disturbed sample to find out the unit weight, and R means representative sample. R means representative. At the same time, it is a disturbed sample. Okay, so these are the just a summary of tests to be carried out, and also for the to carry out those tests, what kind of samples you need. Okay, so that summary is given in this table. Okay, so anyway, this table is not from the scope. It is not like in the examination they won't ask these kind of questions, but just for the for your knowledge purpose, I have put this figure. Okay, but from the exam point of view, these are the important parameters. Okay, they will ask you to define undisturbed sample, or they will ask you to write down the features of the undisturbed samples, or they may ask you to define what is representative sample, or what is non-representative sample, or what is the disturbed samples. Those things will be asked. Okay, so many times sometimes what I will do, I will put some portion which may not be helpful for your exam purpose, but from the knowledge point of view, I am putting these tables. Okay, so so wherever some extra portion which I am putting, I will let you know. Okay, so that those who are you can avoid those for the examination point. Okay, so with this I will stop it here. Okay, so in the next class I will continue with the sampling technique. Okay, so and also I have already made a Google Classroom. Okay, so in that classroom, please log in and you can log in, you can, and also the credentials of that Google Classroom also I have shared you. Okay, so please log in into that Google Classroom. You join into the classroom, and then you can download these PPTs and also video lectures. Okay, so with this I will stop this class.